let's begin the Infinity Saga. Nice. So my name is Mihaylov, and I have spent the last 6 years of my life trying to persuade my top managers why we need observability. So don't get me wrong. Don't get me wrong. People always know that they need observability, but they are not always sure why. Now I work as an SRE, Site Reliability Engineer, at MariaDB, and it has been a challenge to be given the time and money to actually produce the observability system that we have right now. So I felt that many of you, and your reaction just proved me that, have the same issues as me, and might share the same experience as I. So in a sense, this talk is the history, the story of how I fought the fight for observability, the truths I found along the way, and eventually the cloud-native, cloud-agnostic, cheap, agile monitoring system that we've built. So along the way, I stumbled upon questions like, for example, why do we need metrics older than 1 day? Why do we need a global view of the data? So when I joined MariaDB, I started thinking how I can bridge this gap of understanding. I focused primarily on the monitoring as the first part of observability, as a starting point for the future development of the observability system. And by the way, it always bumps me how people think of monitoring as a binary. You either have it or you don't. It's just simply more complex than that. And this is something that I wanted to address in my roadmap. I started building a roadmap of a future state-of-art monitoring system that we were going to create. And it was comprehensive. It was 8 pages long. It was supposed to be my starting point for advocacy to the superiors. The first part was what is the current situation and all the issues we have right now. We had lack of efficient high availability. We have a lot of duplications, in some cases up to 8 times the data points. We have limited scope, so not everything was monitored. We basically had no historical data, or limited. Cardinality was a daily thing, and then alerting fatigue also. So not many people were actually watching alerts, simply because there were too many of them. And while the dashboards and alerts were developed, there were no methods like read or used for actually making sure that they are comprehensive, nothing gets missed. And last but not least, the granularity was not optimal, so in some cases we even had retention, not retention, but resolution of 5 minutes for some data points, which, yeah, and also I listed 10 more, but not included in here. And then the next point was what the system would bring, what were the benefits of actually investing in the new system. And actually at this point, I remember my experiences in the last 6 years that people always, not people, but many people mistake alerting and monitoring. They think that they're one and the same thing, and monitoring is much more than just simple alerts. And this is something that I wanted to tackle in the next part. So I started listing the subsystems of the system that we are going to build. Of course, first of all, alerting. So we are going to receive alerts. We are going to be reactively responding to incidents. And the monitoring system will be in charge of that. But once we get notified, we actually use the monitoring system as well to actually gather information, to troubleshoot, to make cognitive decisions, how we are going to fix the issues that we have. But also, we can use it to analyze stuff, to, again, make cognitive decisions, to catch trends, to make trend analysis. And I was just, one example is how are we to know with how much to increase a memory of some application if we do not have the graphs for the last 1 month of memory usage, and many more. For example, when was the last deploy? How was the last deploy correlates with a spike of memory, something like that. So analytic system is one thing that we are covering in this case as well. And reporting system. By the way, this particular this particular feature was something that the top managers found very, very useful, because at one point, the only place that can answer complex questions with live data, like, for example, how many paid customers do we have right now that are actually using the systems, was the monitoring, the global view that we presented. So here, the global view itself is very needed to answer some questions for other purposes than just alerting. And last but not least, we use it for automation. Autoscaling is a simple example of this. Also for auto mitigation. So we knew some incidents are going to happen, and we had some responses queued for those. And the third part, last part, was because it was a roadmap, I was proposing how to implement those features and what those features would bring. For example, we will bring precision. We will be cost efficient, because this is something always catchy when we deal with management and approving of cost. And then we bring single point of truth, single point of management, of course, because we're not going to deal with different systems, only one. And then better security. Some of the information is sensitive, so we have to think about security as well. Better resolution, as I said. We are going to develop dashboards to spread among teams. We're going to be able to patch systems better in the future, and many more. I listed also 5 more. And of course, always cool graphs deliver your point better. So I also implemented some cool graphs. And yes, I was given the opportunity to work on this system. And at the time, I was part of the database as a service team, which had up to 1,000 clusters, Kubernetes clusters, that is, to monitor. And it was a challenge. But at the end, we built using Thanos. So Thanos was the weapon of choice in this case. We built a multi-cloud, multi-cluster, multi-environment monitoring system that looked a bit like this. Cool graph, of course. But yes, of course, there were a lot of restrictions. For example, there was no easy way to expose endpoints on the customer environment. In this regard, we had to use, in most cases, a remote write and Thanos receiver. But also, in some cases, we were able to implement the sidecar approach. So even now, we see how we are agile. So this system was supposed to be agile. And even in this regard, we are proving that we can deliver different kinds of approaches. Then it had to be cost efficient. It had to think about cost efficiency in every step of the way. Then the data had to be kept regional. And finally, there were a lot of restrictions in terms of we were not able to efficiently patch and deliver changes on the customer side to, for example, filter metrics, or to deliver any kinds of config updates on those. We ended up with a multi-layer Thanos setup implementation. And in this setup, there were different kinds of clusters, monitoring clusters. And the crucial part was the original core cluster, which you see now. And the regional core cluster was just a full-featured Thanos implementation with most of the Thanos microservices on it. It was deployed in every region, in every cloud, in every environment, and it was supposed to be an entry point of all Prometheus remote writes from all the clients. And yeah, we used remote Thanos receiver, but in some cases, Thanos sidecar. But we kept the local data on the receivers, on the sidecars, to the minimum, to 6 hours of data. And the rest we put in block storage. So at the end, thanks a lot for the Thanos guys for implementing sharding in the Thanos store, because we put most of the resources and the effort in actually optimizing the Thanos store in every regional cluster, so that we are efficiently storing the metrics in block storage, also queuing them in the store. And this also brings us to 2 years of retention, which was super useful. Finally, we had redundancy. Finally, the system was dynamic enough. At this point, we also introduced horizontal port autoscaling for Thanos receivers, for Thanos receiver routers, for Thanos queries. I'll talk more about this in a while, but I just quickly wanted to say that we used Prometheus adapter because we used Prometheus adapter to feed Prometheus metrics rather than memory and CPU to actually make the autoscaling on requests rather than memory and CPU. This proved to be super efficient because, like, for example, more remote writes directly correlate with more agents that we needed and stuff like that. And yeah, of course, the filtering, Thanos receiver also has this cool feature that you can actually make filtering on the Thanos receiver routers. So, for example, one thing that popped into my mind when I was thinking how should I represent it, why we needed filtering of the metrics was we had many Kubernetes clusters in the multi-cloud environment that we, for example, EKS, GKE, so on and so forth, and we collected etcd metrics for those clusters. But we have no responsibility about the etcd, so I just dropped those. And then this was the regional cluster in every region, in every provider. Then we had one global core cluster, which is the small box on your right. This was supposed to be a global view with Thanos query on a global level. That was supposed to point to each and every regional cluster and only collect the data from it. And this is only possible because the Thanos query has this option with which you can actually choose your endpoints, your store API endpoints, which can also be other Thanos queries, which was very cool. So we could actually point to every cluster and have a global view and still do not load a single environment, but spread the load towards every environment. And this was in GCP, but it is a cloud-agnostic cluster, so the global core cluster can be in every environment. And yeah, we ended up with this picture, multi-environment, multi-cloud, multi-regional clusters with a single global cluster that can view the data. In the single global cluster, we also added Grafana, of course. We added Alert Manager. We also added rulers to actually check each regional cluster if they are up and running. We also added Slack integrations, monitoring integrations, and it was all good. There were several caveats here. We actually found that rules evaluation is a very costly operation. So putting it on a global environment actually created super huge amount of network traffic. So we ended up deploying the rules evaluation on a local level, on the regional level, sorry. And also, we actually realized that the global core cluster was stateless. So it didn't collect any metrics at all. So it was easy to deploy it in every environment. We used GCP, but it was we could easily deploy it in AWS and every environment everywhere else. So it was very agile at this point as well. Yeah. So also at one point, we introduced Thanos query frontend, which proved to be very efficient because it decreased the amount of out-of-memories in queries all around the environment. It also brings better parallelization, better load balancing for queries. And of course, we introduced memcached as well to cache some of the queries. So this was actually very efficient with horizontal pod autoscaling to scale the loads of Thanos query frontend. And the end result was that we built the environment with the cool graphs, and the cool graphs started making some traction. Started making traction. Teams actually liked it. And other teams started asking if they can join, which was very cool for me at least. And I think at this point I was talking about how monitoring is not alerting, but I want to talk about alerting because, yeah, the first point, the first thing that caught the eye of many people was the cool Slack integration. And I spent a lot of time actually designing it to be simple. And this was my first thing that was supposed to tackle alerting fatigue, because people were mostly overwhelmed by the amount of information that they receive in an alert. And you can see in those two examples that, first of all, they are color-coded. So yellow means warning, red means super high priority, green also would be resolved. Then the title is super simple. Pod is waiting. Pod is terminated. Then where is the environment? Just to know if it's for you or for the other guy, I don't know. And then everything else, it's just a starting point for your troubleshooting. If you are a Prometheus guy, you know PromQL, go check the source, the Prometheus metrics in Thanos, of course. Then the silence button was also a great win because people were complaining there are too many alerts. So I taught people how to use the silence to actually silence those that they know that they are produced by their work. For example, here you can see that this pod has been restarted 400 times, and it was a test environment, and someone was testing. So of course you should silence those. And then, you point to the dashboard, you point to additional resources like, for example, runbooks. And at one point, we also included buttons for logs to point you to the logging system, to Confluence as well. But of course, a point comes into every company when cost saving is a priority. And unfortunately, the systems that do not generate a direct revenue are the first on the list. So we had to think about cost saving even more. But luckily, we already knew how to do that. So we implemented horizontal pod autoscaling, as I said before, to be even more agile, even more cost efficient than usual. Then we somewhat implemented chaos engineering because we put up to 70% of the infrastructure on spot instances. And this was primarily possible because we implemented pod disruption budgets. We implemented topology spread constraint, which actually said, divide the workload between spot and non-spot nodes. We implemented priority classes because we simply realized that, for example, ingesting metrics for us is more important than actually reading or having the historical view. And of course, we over-provision everything. But some of you may wonder, but okay, you put your workload on a spot instance, but the spot instance doesn't tell you when it's a shutdown of the node. So It's not something under your control. This is right, but to a degree. For example, in this example, AWS actually give you a metadata information up to 2 minutes before the shutdown of an instance, which you can query and know that your instance is going to be shut down in 2 minutes. So this gave us, we wrote a simple termination handler that gave us the ability to actually evacuate a node and evacuate a node beforehand, therefore actually give the system more time to spread the workload elsewhere. And the end result was the system was even more robust, even more cost efficient. It was, I don't know, super cool to see that it was still working after all this. But yeah, again, a pivot point came. The business changed. The company reached a life cycle change in which structural decision has to be made. The database as a service platform was no more. The project was restructured. There were no longer 1,000 clusters for us to scrape. The SRE team, we were restructured elsewhere. We were under new management, so basically the same battle had to be fought once again. This time I got questions like, for example, why do we not use this other monitoring solution? Isn't Prometheus only for Kubernetes? No, it was not. And the new demands were no Kubernetes, so multi-cloud environment still, but standalone instances. We had to think about multi-tenancy, and again, thanks a lot to Thanos for actually implementing multi-tenancy and actually implementing the restriction to force multi-tenancy as well, because in some cases this was very crucial. We had to think about on-prem setup, how to put a small portable version of everything on an on-prem environment, how to deploy a partial setup of everything. And yeah, actually, the end result was it was super easy to do because we knew the system. We actually implemented it from scratch. We are cloud native, and this brings us to be super agile when doing stuff, when implementing new solutions. If they're, if they're done correctly, if we know what we're doing. So at the end of this life cycle of the system, still it was very efficient. Still, it was very useful for us, for the SRE team, and also I was very happy to see the screenshots of my dashboards that I built in the product presentations, which was the whole point in the roadmap that I started, because the monitoring is much more than just observability for the SRE team, but it's much more than that. It's much more than just simple alerting. Yeah, so my conclusion at this point will be that it was fun to actually spend a lot of time to develop this system. But while doing so, I realized that we never built it for a particular project. We never built it just to be a compliance check in some compliance report. Yeah, we have monitoring. We build it to facilitate the needs of our team, to be better site reliability engineers, to deliver faster site reliability. And my theory is that the monitoring system is much closer to the SRE team than to any project. So in a sense, the SRE team and the monitoring system go together and cannot do one without the other. Thank you.
Thank you so much. Time for questions and a small gift.
Oh, thank you.
Any questions? Going once. Twice. Oh, yes, we have one. I'll run.
All right, thank you.
Thanks for the talk. I really like the screenshots of those Slack alerts. I was wondering if the silence button actually goes and silences the alert, or whether it just takes you to the alert manager UI, basically, for you to then press the silence button.
Yeah, very good question. I was so used to this, so I didn't think about people not knowing that. But yeah, of course, the silence button actually opens Alert Manager and fills all the labels in the alert, which was very useful. And just to, so people could use it and just create, and this will create a silence for 2 hours. We were advocating just do this and it will be okay, because 2 hours is usually enough time to have enough silence for you to be ready with what you're doing. But yeah, so it gave you the ability to actually pre-fill the data in Alert Manager. Yeah.
Amazing. Any other question? If not, then thank you so much, and it's time for break.